Hello guys, welcome back to my channel. If you have already subscribed, and make sure to like, subscribe and stay tuned for new videos if you are new to this channel, Mr. Electric DIY. In today's video, we are going to talk about 4 basic things to check on a contactor before you use it to do either your project, your domestic work, your commercial or even industrial work. These are 4 basic things, and don't forget that the basic things are actually the professional things, and the professional things are actually also the basic things. Let's get started. Number 1, you have to check the continuity of the power terminals, and you can see that we have line 1, line 2, line 3, and we have number 1 actually here, and number 2 this side, number 3, number 4, number 5, number 6. This is how contactor numbers are arranged if you are new to contactors. We are actually going to check the power terminals, whether it has continuity or not. So I have my data multimeter here. We are going to use it to check whether the power terminals has continuity or does not. It's very important to check it before you use contactor. I've tuned it to continuity. Yes, that's the beeping. Now I insert one side of the probe to this side, the other side to this side. Now I push the contactor. It has continuity. This side too has continuity. This side too. And don't forget to check the normal open. If you are doing direct online, this is the hold on. And I'm not going to talk about that. These are the 4 basic things to check. So I'm actually focusing on the 4. Don't forget to check the normally open. This side is also working. Now we are done with number 1. Let's move to number 2. Number 2, check the rated voltage of the coil. The rated voltage. Now don't forget that we have AC contactors and DC contactors, and this is actually AC contactor. I can actually tell from looking at the coil voltage. There's a coil inside this contactor, and if I connect my supply A1 and A2, the live and the neutral, and the neutral is always connected to this section, the A2, and the live to A1, depending on the country. Some countries can interchange them and it will also work perfectly, but maybe your country like Ghana, don't do it like that. It will work, but if you do that in school, you'll be marked down. Your teacher is actually going to mark you down. So always your neutral must be connected to the A2 and the live to A1. That's the way we do it. And this is the coil voltage, 220 volts. This is AC 220, not DC. AC 220 volts. This is actually single phase. You can if your single phase voltage is 230 or 240, it will work. And it's very important to always check it before you give your supply to it. Let's assume that this is a DC contactor, and maybe the user, the one going to use the contactor, that person has been using single phase contactors. So the person might not check. He will just come and connect the live and neutral to it, not knowing it is DC contactor, and the person is actually going to damage the contactor. And we also have contactors that has the coil voltage is actually 415 volts. They are there. I have one here. You can see this is 380, and the same as the 415 volts, depending on the country. You can see that we have 380 volts here. This is the A1 and this is the A2. So if you want to energize this contactor, this type of contactor, how to actually connect maybe line 1, line 2 or line 2, line 3. It will work before this contactor will be energized. If you don't do it that way, and maybe or you don't check and you give either DC voltage or AC, it will not work the way you want it. So always have to check these things before you do. And you are done with number 2. Let's move to number 3. Number 3, check the rated current, and you can see that this is the rated current. You have ITH, meaning thermal current rating, and it is actually the maximum current rating of this contactor. So don't forget to check these things. Current rating of the contactor, meaning it's the terminal current rating. If I connect a cable at this place, or either from this side to your overload relay, and from the overload relay to the load, either a motor or whatever the load is. And let's say it is 3-phase induction motor, and with that induction motor, it has, let's assume that the induction motor has 30 amps. The current rating is 30 amps, and this your contactor, the maximum is 20 amps, and your motor is actually drawing a current of let's say it is 30 amps, so let's say it is drawing, let's say 28 or something like that, and this is 20. Within few days, or even the moment you connected, it will just burn out. The terminal will burn out. And this 20 amps, the maximum current. If I connect this side, one cable here and one cable here and one cable here, it is only this side that it reaches more than 20 amps. That's either the contactor will either burn, not something like here supposed to be 20, here 20, here 20 before it will burn. If only this side reaches 20 amps, if you have connected it, either maybe you are using it for a storage building or something like that, it's only this side that reaches more than 20 amps that the contactor will burn. Sometimes it will cease, this side will be in. So always have to check these things before you conduct electrical work using this contactor. And I've said earlier, there's only one side that when it reaches the 20 amps, it will start, something will start happening. It will heat up and it will burn. And last but not the least, and I'm sure this thing you don't actually check, and it is very important. You have it here, the AC type. You can see that this contactor is actually AC3. And we have so many type of this contactor. We have AC1, AC2, AC3, AC4, AC5A, and even more than that. This AC3 contactor actually for squirrel cage motors, and this type of contactor can withstand high continuous current. This type of contactors can withstand it. We are actually done with the 4 basic things to check before you start using this type of contactor. If you find this video helpful, subscribe if you haven't for new videos.